Hello again everybody. Today we're looking at scatter charts in R. Previously we looked at bar charts, histograms and box plots. Okay, so for scatter charts we're going to actually move away from the imported data that I've provided you previously. We're going to use the core iris data set that's included in R. So scatter charts in R. So I'm going to iris df is going to be the iris data frame. Just going to make sure it's cast as a data frame. Iris. Okay. So run that. That will appear under 150 observations of 5 variables. So we've got is different length and width of sepal and petals in flowers and which species they belong to. Normally used for classification tasks, but it can be useful for data visualization as well. So what we're going to do, because we've saved time there, we can just check the head of that data frame. You can see, yeah, that's exactly what we've just viewed. Okay, so we're going to create a scatter chart. And a scatter chart is normally used to look at a correlation between two variables on an x and y axes. That's the purpose, it's to illustrate correlation. Okay, so we're going to call it scatter data and AES. LYR we're going to put this time. ggplot is the package we're using. Oh, we're not at all. I've missed it myself, bad Gary. So ggplot2, we're going to make sure we reference that library. So data comes as second nature, you just forget sometimes. So the data is the iris data frame. And my AES layer is going to be X. We're going to have that as iris df, and we're going to have the petal length by the Y iris df. Let's see if that correlates with the sepal length. Okay. So that's created the values in there. Now what we need to do is create the plot, the scatter plot. So we're going to use the previous data and aesthetics layer we created, named scatter data and AES layer. We're going to add to it a geom underscore point geometry. If I run that line, that'll have created my plot. Now I need to print out my plot to the plots window. So I run those 3 lines just to make sure everything's gone okay. Okay. So you can see there's clustering. Not sure about correlation on any kind of regression line because there's clustering here, but it's just to illustrate how you'd use scatter charts. Okay, say I want to add the an additional feature to my scatter chart. I'm going to rerun the plots. I'm going to create plots with features. And this time, add additional features to scatter. Plot with features. So this time I'm going to use the previous data layer that we've created there, data and aesthetics layer. So the same data essentially. Scatter data and AES layer. And I'm going to put geom point P, choose from the list, tab, AES, so we're going to add aesthetics layer, and we're going to colour each one of our points. Basically this is what it's saying. Colour each one of the points. I'm going to use the English spelling of that. I didn't say correct. Iris df, and then we're going to do it by the species. So by a factor. So now if I run plot with features, that's gone into my values window again. But again, we need to print that out because it's basically a placeholder stored in memory. Until you tell R what to do with it, it will remain in memory. It will remain there while the life of this project remains. So, and then it'll go out of scope basically when you close it down. Print plot with features. Now I've got a nice visual representation of my scatter chart by the different species based on their sepal and petal length. You can see really there is clustering here because you can tell why they've been grouped to setosa. Fascicular, there's a few kind of incorrect guesses I would think from a clustering algorithm, but you've got clustering there in the middle and then you've got clustering here. So yeah, I can see why they've been divided into separate species. But yeah, that then shows you how the data is distributed across those two axes, petal length and sepal length, and it gives you a nice visual representation of the types of species that we've got within that data. What I'm going to do now is actually create another additional feature. This time it's going to be sized based on the... What I could also do, and what I have just done, is create another variable called sized plot. I'm going to use the same data and aesthetics layer again, but what I'm going to do is add some aesthetics to the geometry layer. So I've added a size variable. So basically for each species just increment the size. If it was a numerical variable, what you'd do is you'd create a factor of that variable and pass in, so say it's like on a graduating scale of survey responses, so satisfaction 1 to 5. You could size those points based on satisfaction levels, but you'd need to pass it into a factor command. But for now this is already a factor, so it's going to create me sizes based on the relative factors. And then it's setting a colour based on the species. Another thing I could do, let's extend this down further, is I could create a shape based on iris, df, species. So now I've got 3 different ways of displaying this information. They're relatively sized by the species, they're coloured based by the different species, and now they're going to have a unique symbol shape as well. There we go. So for setosa we've got little red circles. For green we've got middle green triangles, and for virginica we've got blue squares. So that's how it's been altered on the chart. What we could also do is, as we did previously, is add a scale colour gradient to our chart. So we're going to do another example. So we could call this one scaled colour grad chart, and this time we're going to have data and AES layer, scatter data and AES layer, scatter data and AES layer plus geom point. AES is going to be what we had previously, the iris species, so a factor variable. I'm going to set. Then at the end of that, what we're going to do is add scale colour gradient. We have the high value in there. I'm going to just set this to red. Actually, let's say blue. And the low, let's make a really insipid chart. Pink. Okay. So that's got a data and aesthetics layer. It's got a geometry layer, and then it's got a gradient layer, so a scale colour gradient layer added to that as well. So now what I want to do is print out that scale colour gradient layer, and let's see what happens. not what I'd expect. Ah! And that's how you'd add a coloured gradient onto your chart. Next one, we're going to look at different lines that you can add to your data in your chart. So again, I'm going to put regression lines in scatter chart. Okay. Regression example 1. And call this. We're going to use the scatter data and AES layer. We're going to add just a simple geom point. We're not going to pass any values to that. And we're going to add something onto the end of it called a smooth line through the data. Smooth. So there's formulas for that. So it's y is equal to z, standard error is equal to true. But yeah, it's basically adds a smoothing line through the data. You'll see that in a second. So if I print out my regression example, you can see a nice smooth trend line has been fitted through the data. It auto fits that line. So if you want to find out more about how the statistics and mathematics work behind it, you can use the help, geom, smooth. Smooth conditional means, and it'll give you how that's then filtered through. Calculation is performed by currently undocumented predicted F generic and its methods. So I'm not going to read all that to you, but that's how you'd do a smooth line through your data. If you wanted to add some kind of linear regression line, which is the one that we're normally used to, I can see this data is not that linear, but we'll do it anyway. So lin reg example, scatter data and AES layer. I'm going to put geom point again. This time we're going to add geom smooth, but inside we need to specify the method is equal to, and we use LM, which means linear model. This will be, we'll go over this in the statistics section when we do single linear regression, so simple linear regression and multiple linear regression. But for now, that adds a regression line and fits it to that chart. So if I print that out, let me just expand this so you can see the full screen. So I print out my linear reg example. So you can see it gives you the errors as well, so the confidence limits. So yeah, it fits the linear regression line through that data. From there I could then change certain elements like my standard errors. I don't want them in, so I'm going to add false. That's the standard error, the little grey area there. And I'm going to change the colour. Getting American now. It goes red. Nice. So seems to have lost my other command there, or is it me deleting it? I don't know. So yeah, as you can see, it gives you a linear regression line which is red. It's got rid of the standard errors. So like you say, there's options again that you need to explore using the help command. Surprisingly enough here, the only downside to these regression lines is it's relatively complicated to add the R² value. There is code out there, so if you need it I can supply that. But for now this is just to serve as an example of how we'd use scatter charts in R. I hope that's been useful. Please keep watching, and I appreciate all your support, and see you next time guys. Thanks very much. Keep watching.